Meghna Parikh, and today we are here to start the lecture series of the Mathematics 1. Okay, our last topic is lecture 15, Differentiation of Inverse Laplace Transform. Differentiation of Laplace Transform, that means Laplace inverse of f of s equal to f of t. We are taking f of t equal to minus 1 upon t L inverse f dash s. Use this formula to find the inverse Laplace transform for the function as a log, tan inverse, cot inverse, etc. Find inverse Laplace transform of log 1 plus omega square s square. First of all, take f of s equal to log 1 plus omega square s square. F of s equal to log s square plus omega square upon s square. F of s equal to, we are applying property of log s square plus omega square minus log s square. Taking differentiation both sides, we get one upon s square plus omega square into 2s minus 1 upon s square into 2s. Okay, this s is cut, only one s is there. So we have d by ds of f of s equal to s upon s square plus omega square minus 2 by s. Apply Laplace inverse both the sides. Okay, so what is the Laplace inverse of d by ds f of s? It is minus t f of t. So it is 2 cos omega t minus 2. Taking f of t as a subject, we get 2 minus 2 cos omega t upon t as an answer. Okay. Again, first take f of s equal to log 1 plus omega square upon s square. What is f of s? F of s is log, taking LCM, s square plus omega square upon s square. F of s, using log property, we get log s square plus omega square minus log s square. Taking differentiation both the sides, so we get left side d by ds f of s equal to 1 upon s square plus omega square into 2s minus 1 upon s square into 2s. Where d by ds f of s equal to 2s upon s square plus omega square minus 2 by s. Apply here, apply inverse Laplace transform both sides. So Laplace inverse of d by ds f of s, inverse of 2s upon s square plus omega square, we directly use 2 cos omega t, and inverse of 2 by s is 2. d by ds of f of s is minus t f of t, it is 2 cos omega t minus 2. We are taking subject as f of t, so 2 minus 2 cos omega t by t is the answer. Taking next example, find Laplace inverse of tan inverse 2 by s. We are take f of s equal to tan inverse 2 by s. Taking differentiation both sides. So it is d by ds of f of s 1 upon 1 plus 4 by s square into minus 2 by s square. Apply inverse Laplace transform both sides. We get Laplace inverse of d by ds of f of s equal to Laplace inverse of 2 upon s square plus 4. Okay. So d by ds f of s equal to 2 by s square plus 4. This is the minus t f of t. And here we get minus sine 2t. So f of t is sine 2t by t. This is your answer. Again, take f of s equal to tan inverse 2 by s. Differentiation both the side. We get d by ds f of s equal to 1 upon 1 plus 4 by s square into minus 2 by s square. Apply inverse Laplace transform both the side. We get Laplace inverse of d by ds f of s minus sign as it is Laplace inverse of 2 upon s square plus 4. Find the inverse. We get left hand side minus t f of t and right hand side minus t sine 2t. Taking f of t as a subject, answer is sine 2t by t. So this is a differentiation rule of inverse Laplace transform. Thank you.